Uh, Hello, my name is Jinhyeon Yun. I'm working in the Department of Animal Science in Chonnam National University, Korea. First of all, I would like to thanks to 중앙대 농식품 신소재 연구소 for giving this opportunity for having this presentation. So today, I'm going to talk about the current challenges of the sows with the large litters in modern pig farms. And I'm going to focus on the oxidative stress of the hyperprolific sows and how they are relating to the modern sow housing systems. And thereafter, I will also introduce some of our ongoing projects, which was aimed to cope with this oxidative stress in hyperprolific sows during gestation and lactations. Before going to the subjects, I would like to introduce myself briefly. I am a pig researcher, and so mainly working with pig behavior, welfare, nutrition, and reproductions, and their health and management in pig herds. I did my PhD in Finland, University of Helsinki. I was working with animal behavior and welfare. And after that, after PhD, I did a postdoctoral. I worked as a postdoctoral researcher in Finnish Research Center for Animal Welfare, still in Finland, and working with animal welfare-friendly farming and biosecurity and antimicrobial usages and antimicrobial resistance in pig herds, and some of smart farming subjects in pig productions. So my research course is that safe and sustainable management in pig productions. For the academic careers, I'm a member of the International Society for Applied Histology, and I'm also a member of the European Society for Food Science and Health and Management. And acting and Helsinki One Health, those are the society for tracking the antimicrobial usages in livestock farms. And I was also working with that. And I'm also a member of the Korean Society for Animal Science and Technologies. So this is it about me. Now let's see the modern farrowing housing system first. So this is the creating system, which has been widely used worldwide and also in Korea. Basically, this farrowing craze can reduce the production cost and the labor work by confining the sows inside of the craze. And it can also further reduce the piglet crushing when the sows are laying down from the setting positions. So the piglets can be protected by these crate bars from being crushed by the sow's body. So the most attractive part for the farmers with this crating system is that it can reduce the piglet mortality, including the crushing. However, as you can see in this crate, sows can only stand or sit or lay down. They cannot move. They cannot even turn around. So this crating system leads to poor sow welfare, mainly due to the behavior restrictions. And therefore, for this ground, some European countries, for example, like Sweden, Norway, Switzerland, or Finland, and Finland as well, and these countries banned this crating system in pig farm. And from now on, after declarations of cage-free in EU farm animals, this crating system cannot be used in EU countries from 2024. And I assume that most likely these issues will be soon applied also in most of the Asian countries, including Korea as well. Then what are the alternatives? Here are so-called non-crating system or loose housing or free farrowing system. So this can be the alternatives to the crating system. The idea of this loose housing system is providing at least the space for the sows so that they can at least turn around. then they can express their innate behaviors around farrowing, which is the nest building behaviors before parturitions, has been well reported as the most important innate behavior for the farrowing and lactating sows. So sows can have, and also sows can have the maternal interactions with their piglets during lactations. But the problem of this root housing system was that the piglet crossing could be increased, particularly in early lactations, because the piglets have no protection bars when sows are lying down. However, if the sow is housed in root housing system and has the moderate size, the crossing rate would be increased, whereas the other mortality caused by, for instance, like starvation or weak vitality, this can be reduced. So the total mortality rates in moderate litters was not increased in root housing system. But again, those studies were done almost 20 years ago when the sows had the moderate litter size. Then, what about litter size at the now? Over the last 2 decades or earlier than that, their litter size has been dramatically increased. Actually, I've been always surprised when I see this academic data showing their litter size. This graph shows the number of the live born piglets. I mean, it's not like a total one, but live born piglets. And the data were collected from the Danish Pig Research Center. So it's not from the commercial farm, but from the experimental farm. But anyway, the live born piglets were about 14 in 2007. And like 5 years later, or it was like a 16 or 6 years later. And then another 5 years or 6 years or like 6 years later, or it was like almost 18. And then about in 2020, it was about 20. Actually, the paper said it was 19.4 in 2002. So since 2007, almost 2 live born piglets were more born in every 5 years. And more surprising part is that this rising litter size is still ongoing. It's not just not like a stable. It is still ongoing. The increasing the litter size, and this Dan breed sow is now quite familiar to the Korean pig farmers because it's now one of the most common breeding sows in Korea for the farmers. However, these hyperprolific sows have been showing many problems during farrowing and lactating in terms of their welfare and productivity as well. Firstly, the farrowing duration has been delayed more than double. And with this prolonged farrowing, of course, sows get more stress, and these more piglets stuck in birth channels, leading to increasing the stillbirths. And also decrease the vitality, which in turn increase the crushing risks during farrowing or early lactation. And secondly, the hyperprolific sows farrow more births with low birth weight piglets, and the birth weight variation within the litters has been very much increased with the rising litter sizes. So these all cause the increase the piglet mortality, particularly in low birth weight piglets. Let's take a look more closely or more carefully about what are the factors, or what are the original factors leading to the piglet mortality in large litters. And I'm sorry for the busy slide, but let's see. Let's start to looking at here. The piglet deaths or piglet mortality, piglet deaths can be more often occurred if the piglet birth weight is small. And the smaller birth weights can be affected by the low litter uniformity, affected by poor embryo development, which is affected by poor follicle or like corpus luteum qualities. And therefore, you can see that this line is mainly originated from metabolic challenges of the hyperprolific sows. And then piglet deaths can be also increased when their vitality is weak. And this line is more closely relating to the limited utility capacities. So this is more like the adversely affecting the parent progress. So because of this sows has limited utility capacity, the large litters can lead to poor placenta qualities and thereby the poor the beta growth. And then the last line is originated from overloaded milk synthesis when the sows have many piglets. So this adversely affects milk productions and milk intake of the piglets. Then piglets could get more starvations, and then they could be becoming more inactive, which could then increase the crushing rates and thereby increasing the total mortalities. So some factors are closely affected one another, but I would like to point out here that these are the functional the factors affecting piglet deaths in large litters. So because of these challenges, basically the hyperprolific sows undergo the oxidative stress due to excessive production of ROS during gestation and lactation. And this oxidative stress adversely affects not only fetal and neonatal growth retardation, but also it leads to increased stress hormone of the sows. And thereby this can inhibit the production and secretions of the regulatory hormones for parturition and lactation, such as the prolactin and oxytocin, which can lead to poor maternal characteristics. Thereby, these factors are also going back to affect all these lines again and repeatedly. So let's keep this mind in these functional fundamental factors in order for this to my study ideas. And my next question is that when you still keep piglets safe without crating in large litters, what about housing in large litters? The colostrum, as we all know, the colostrum is a key source for the neonatal growth and survivals. So as we all know, for neonatal survival, the colostrum is the most important part, and thus, in order for improving colostrum intake of neonates, we need to consider all these factors like sow capacity and parenting, sow nutrition, and the breeding status and metabolic status, and also the stress, which is induced by the parent housings or the management or like temperament in sows as well. So if the optimal parent environment can be provided to the sows, these all factors could be favorably improved because this optimal parent environment can reduce the stress, and this stress can favorably affect these all factors, so that this can lead to improve the piglet survival in large litters by improving the colostrum production and colostrum intake. Then let's see my study idea, how it comes from. So my hunch is that in these large litters, if we can control this oxidative stress, this may lead to induce the regulatory hormones for parturitions and lactation and also reproduction. So this can be the key to improve the parent process and nursing performance as well, and also reproductive performance, and thereby it can contribute to neonatal survival in large litters. Then my next question is going to be how? Well, many earlier studies have been focusing on the using antioxidants in sow feed in terms of the nutrition balance. However, in modern pig farm, in modern pig farming, the nutrition balance is quite well managed, especially in sow feed. So there's not much room to develop these antioxidant feed additives. Furthermore, in fact, their performance have been showing somewhat limits for the managing this oxidative stress in the currently hyperprolific sows. Therefore, I came to think that in addition to this antioxidant, I thought it may also be some optimal the housing environment for these sows. Because as I mentioned in previous slides, the optimum environment for the sows is quite important for those regulatory hormones as well. Therefore, I hypothesize that the provision of these combinations of between the nutrition factors and also the environmental factors, this would contribute to control the oxidative stress of the hyperprolific sows, and together with improving the hormonal balance, this can be the key for the piglet survival in these large litters. So we just started our own project, which aims to optimize the farrowing environment under the climatic conditions in order for the regulating oxidative stress of the hyperprolific sows and improving their welfare and the productivity as well. And from now on, I would like to share this study plan and some of the outcomes currently we have now. This study can be divided into 3 phases. At the moment, we are somewhere here in the middle of or between the second and third. Firstly, this study will identify the oxidative stress in the hyperprolific sows. Then we'll find a way to regulate this oxidative stress in the optimum farrowing and the lactate environments where the sows, the behavior needs are fulfilled. Then finally, we'll investigate their associations and find a way to manage the piglet survival in large litters in the current farrowing housing systems. In the first study, we compare the hyperprolific sows against the non-hyperprolific sows on the oxidative stress parameters, cortisols, cortisol levels, and some of the behavioral parameters. How we classified between oxidative hyperprolific sows and non-hyperprolific sows. If the sows farrowed more than 15 piglets, we classified the sows as a hyperprolific because their functional teats are only 14. So we had altogether 16 hyperprolific sows and 12 sows as non-prolific sows. These sows farrowed the piglets with the number between the 8 and 14. This is the farrowing housing system. So the sows are the 7 days before expected farrowing days, they transport to this unit. So this is like a huge housing system, but according to the farm procedures, the sows are during farrowing and about 4 days after farrowing, the sows are confined in these farrowing systems. So this is kind of the movable, the farrowing systems. And during the gestation period, sows are housed in the group housing systems from 30 days of pregnancy until 7 days before the expected maturation date. So this is the gestation housing systems. Here, this graph shows the oxidative parameters, so hydroxyperoxide and AUPP and THC and TNF-alpha. So we found the hyperprolific cells had higher all oxidative stress parameters. So during gestation and lactations. So you can see some before patulations and lactations, like the hydroxide peroxide levels is higher in large litres, and also the gestation was high, and also TH level, it shows some like antioxidant capacities. So which means the lower levels means the hyperprolific cells undergoes more oxidative stress. And TNF-alpha, you can see some the higher levels in cells with large litres. So we expect that these hyperprolific cells undergo more oxidative stress compared to these non-hyperprolific cells during lactation and lactation period, which is corresponding with our expectations. We also analyzed the cellular body cortisol levels. As you can see, in order for determining physiological stress. So you can see these cortisol levels of the hyperprolific cells are much higher during late gestations and also the lactation period. This graph shows the prepartum nest building behaviors by the times. We analyze these behaviors 24 hours before parturitions, and you can see the hyperprolific cells start this prepartum nest building behavior later than the normal prolific cells. And all the durations, the frequency of nest building behavior shows the higher numbers in normal prolific cells compared to the large cells. This is an interesting result. This is also contrast to the other findings the previous studies. We think that these nest building behaviors can be initiated by the prolactin levels, but these prolactin levels can be associated with the oxidative stress. So when the cells have the more oxidative stress, then the prolactin levels can be reduced. So we assume that these hyperprolific cells, because they undergo more oxidative stress, then this reduce the prolactin levels, and that's why they show the less nest building behaviors compared to these normal prolific cells. Hyperprolific cells shows shorter durations and shorter frequency, the less frequency of the successful nursing behavior compared to the normal prolific cell. Successful nursing means when the piglets showing like real suckling behaviors, then the real suckling motions, then we classify these successful nursing behaviors. And we think that this outcome is also because of the hyperprolific cells might have lower level of the prolactin levels and oxytocin levels due to the higher oxidative stress. Then for study 2, how can we regulate this oxidative stress over the hyperprolific cells? This is going to the second study. And for this, we provide to the cells with a supplemental antioxidant, which is the megadose with the vitamin C, together with the optimum ferroin and lactate environments, as you can see here. And here's I think you might wonders what is the optimum ferroin environment under the commercial conditions. Elite cells need space to perform their innate behaviors. And regarding this innate behavior of the peripartum cells, the most important behavior is the nest building behaviors. And because many studies, including my PhD work, found that these behaviors is connected with the regulated hormones for parturition and lactation. So the ferro environments for the peripartum cells need to fulfill this behavioral needs. In these experimental farms, they have the more space so that at least they can turn around. This is the ferro pen for our experiment. And we provide like a natural match that was made by a coconut shell. So it's called like a coconut core mat. It's a chip, and the best nesting materials as known for is the straw in European countries or in other United States as well. But in commercial pig farms, especially in Korea, we cannot use straws or haze because this of the selective floor systems. If we use the straws, we can directly go into the slurry pits, so they can stop with the slurry pipes, or it can also disturb some like water pumps if they use some like these systems. So in this kind of selected floor systems, the materials the materials should not be penetrated the floors. So these coconut core mats, they can be still safe it's also safe for the sows, the animals, because this is made by the natural sources. And it can also used as a safe in the farm the management, because it cannot penetrate to the systems. So I can show some this data. This is my PhD work. So how the nest building behaviors are important. As you can see, this graph shows how many animals the sows perform the nest building behaviors. So when the sows perform more pre-batch nest building behaviors, where they have more of the oxytocin levels, and they also have the prolactin levels. So these are the regulated hormones for instance, the mainly for the pairing and during the lactation times. So I can show some what is the nest building behavior look like. So now she's trying to routine with material, and she can show you some like a point. I can also show some like a foraging. So these three behaviors, routine, point, and foraging, is the main the source of the nest building behaviors. So the sows perform these nest building behaviors starting from 24 hours prior to parturitions, and they can show some like a peak of these behaviors between 12 and 6 hours before parturitions. So if they cannot perform these nest building behaviors, they can show these behaviors after parturitions. So the sows can they show some more emotions during the parturitions, which can increase the risks for the people that crossings. And also, if they cannot perform this nest building behavior, their stress can be increased. So this stress can increase the opioid receptors, which then those opioid receptors can inhibit the productions and the secretion of the pituitary hormones, most likely the oxytocin and the prolactin levels. So they cannot perform these nest building behaviors, then they can adversely affect to their pairing and lactating performance. So this is quite important behaviors for the pairing sows in terms of the welfare and the productivity as well. So far we measure the follicle development. So this is showing we're using some like a transrectal ultrasonography. So here's some data shows some when you use the antioxidant as we use using the vitamin C supplementations, we found some the smaller follicle developments after weaning, 3 days after weanings. But when you use these nesting materials, but there's no differences between controls and the testing materials to provisions. But we assume that this antioxidant supplementation with this high dose of vitamin C, it acts as a pro-oxidant, so it can adversely affect to the antioxidant the functions. Whereas it can increase rather increase the oxidative stresses on the cells. So this is adversely affected due to these other ferroin hormones, and also decrease the performance of the ferroin and the survival. So far, we have complete data collection for salivary cortisols. And as you can see, the TNF alphas and the hydroxypeptide and pH and LPP, as you can see the results. And also I show these like a follicle development with the figures. And we also collected some like a fecal samples for measuring the microbiota. Determine the microbiota. And we also collected the colostrums in order to determine the oxytocin levels and prolactin levels, and also immunoglobulins. We also recorded the sows and piglets for analyzing the maternal parameters. And during the sampling collections, we found some difficulties in our experimental farms, experimental pen, which the crushing rate was quite high. Usually, this farm close these crates during the farrowing and early lactations. Like they combine the cells during because the combine cells during farrowing and about 4 days after farrowing, in order to reduce the piglet, in order to reduce the piglet crossings. But we decided to keep these crates open for these studies, and this posed the many piglets crossing from like a smaller one to, but also there are some like bigger piglets has been crossed. This pen does not have the piglet shelters, but instead there is a little space for the piglets for avoiding this crossing. But we observed only few piglets staying here, and most of them were in the middle of the pens, close to the cells. I think that's why the crushing rate is quite high in this pen. But in this pens with this coconut core mats, we used these mats as shelters. Actually, after cells performed the nest building with the mats, it was unraveled and became like this. So we moved the mats to underneath of the headland, and then we could observe that the many piglets spontaneously moved to this area. So in this kind of pens, provision of nesting materials, they can be also useful for physically protecting piglets from being crushed. And so what we are expecting in this study is that we would be able to determine the risk factors affecting piglet mortality and health of the sows with large litters. And I think we can also cope with these challenges that can improve the fertilities and welfare of the happy sow. And we also expect to develop the optimum pheromone environments under the commercial conditions. Then it can contribute favorably to moderate reproductive hormones. Then it can also, our study can inform the strategy to improve the success rate of the reproductive management in large litters. This study was funded by the NRF with the Beijing Research Labs. So we thank for that. And we also thank for the experimental fund. And mainly also I also would like to thank to my pig production labs, the graduate students. And thank you for your attention for And I would like to also thanks to other